Hi everyone, I'm Joe Kai. Today, our group will introduce you guys some basic information about Internet of Things. As we know, with the development of technology, the Internet of Things has gradually entered our lives. This technology can achieve the interconnection of devices on the Earth to form an interconnected whole. Analysis predict that by 2020, the Internet of Things will include up to 26 billion connected devices, a 30-fold increase from 2009. And this is the outline of our presentation. I will introduce the part of the define the IoT and the origin of the IoT and the technical standards of the IoT. Jingdi Lin will introduce some influence about IoT, and Jesse will introduce some skill that postgraduate students grasp for the IoT and some preparation for IoT. The Internet of Things is a system of interconnected computing devices with special identification symbols that can transmit data to each other over the Internet without human intervention. People widely deployed embedded identification on devices and connect devices to form a considerable devices network. The concept of IoT was first discussed in the 1982. People modified the Coca-Cola vending machine at a famous university to form the world's first IoT devices. Those devices are able to report the inventory and whether the beverage is cold. Now, the Internet of Things has been widely used in various industries, for example, agriculture, manufacturing, transportation, and so on. To achieve the Internet of Things, the communication network between the component devices is one of the most critical technologies. With the rapid development of the technologies, more and more communication technologies have entered the market. And now, the mainstream IoT communication forms mainly include the following four types: short-range wireless, middle-range wireless, long-range wireless, and wired. Among them, the short-range wireless is one of the most popular way in the market. And the technologies that are widely used in short-range wireless communication are Bluetooth mesh networking, radio frequency identification, light fidelity, and Wi-Fi, and so on. And for example, with the support of RFID technologies, people can complete electronic payment in the form of near-field communication. Now, most of the bank card in our hand support this function. When we need to pay, we only need to touch the bank card on the POS machine, and the payment can be completed immediately.
We know that the Internet of Things refers to the interconnection and exchange of data among devices. And now IoT has been connected and used for a variety of purposes, including sensors, development, and analytics requirements. This huge space of applications has brought great impact to life and work, and also ask for a solid supply of IT technologies. Broadly, the application requirements can be classified concerning the type of them, like monitoring, control, and optimization. To be more specific, it can be smart parking, pollution monitoring, forest fire detection, and so on. It can be further subdivided into different classes based on these: the number of sensors, data traffic nature, data traffic size, system latency, coverage area, and analytics complexity. These complex divisions imply it's useful to abstract them into a set of categories, like the table here. In fact, The IoT factors and technical differences will determine their feasibility for specific applications. This means one technology cannot equally serve all IoT applications, but a combination of them can make sense in real life. For example, according to Mackie, in the electric metering market, companies typically require frequent communication, low latency, and high data rate. They require neither low energy consumptions nor long battery lifetime, as electric meters have a continuous power source. Moreover, companies need real-time grid monitoring to make immediate decisions, like load outages and interruptions. So for scientists and engineers, it's meaningful to consider best fitting combination for certain circumstances, and also develop technologies to meet the need for extreme environment.
I will do the third part of this presentation. As my partner said, it can be seen IoT is a comprehensive subject, including communication, computer science, and electronic engineering. This means that study and analysis of equipment, technologies, and data are important ability for students. This means in the IoT, device and data play an important role as a input process. First of all, RFID sensor system should be needed of student in the future. Device can contact it to the internet in different ways. So the master of M2M technology is the major demand of IoT in this stage. In addition, with the developing of the chain based on M2M technology, there must be increase the research on RFID and the sensor systems. Therefore, for the student is not only a master of M2M technology, but also need to RFID and the sensor system technology skills. Secondly, in the level of data, machine learning, database, cloud computing technology are the ability of students in the future, including SQL, NoSQL, IoT through the technology to analyze and apply the data from the sensor system. As a result, some technology have been development to copy SQL database. Finally, although the data still collected to the local service, cloud computing provide a low cost and high product. In the last part of this presentation, I would like to introduce the preparation of IoT. I think there have two aspects can help students better prepare for IoT and master its knowledge. Personally, I think school can provide students as many protect opportunity as possible. For example, they can contact with some related professional companies and people who working with IoT industry to conduct lecture for students. It will help students to update their own knowledge, and the people also can share their experience in dealing with problems. School also can provide students with some project so that they can understand their major more clearly. And secondly, school can provide courses to students more effectively according to the direction of employment. Let students be more clear about what they want to do. Due to the wide field mode of IoT and the limitation of different countries on the developing of IoT, sometimes the student really don't know what they want to do. and they also don't know their own positioning when they after graduation. Therefore, the effective curriculum division enables students to better develop in the professional field after graduation. In conclusion, in this presentation, we talk about the definition, technical standard, and the aspect of IoT. And in the last, we also discussed the skill of students and some recommendation on how to prepare for the IoT. Thank you.